Hari Om children, welcome to Max class. Let's start our class with prayer. Sit straight, join your hands, close your eyes, chant Om 3 times. Take a deep breath. Om. 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 Om Sagana Bhavatu Saganau Bhunaktu Sahaviryam Karavavahai Tejasvinavaditamastu Mavit Vishavahai. Om Shanti Shanti Shanti. Hari Om Shri Gurubhyo Namaha. Hari Om. Learning objectives. From this class, children are going to understand about section formula.
The section formula says that if we have 2 points A and B with coordinates x1, y1 and x2, y2, if the join of AB is divided by the point P in the ratio m is to n, the coordinates of P being x and y, then according to the section formula, x is m times x2 plus n times x1 over m plus n. And similarly, y is m times y2 plus n times y1 over m plus n. Now let us try to derive this formula. So let us draw the coordinate axis. We have a point A, point B, the coordinates x1, y1, x2, y2. There is a point P, the coordinates are x, y, and it divides it in the ratio m is to n. Let us drop a perpendicular AT, a perpendicular PU, and a perpendicular from B on x-axis BV. All these 3 lines are perpendicular to x-axis, so they are parallel to each other. From A, we drop a perpendicular on PU and label it as AD, and from P, we drop a perpendicular on BV and label it as E. Okay, so here we see that BV is equal to Y2, PU is equal to Y, and AT is equal to Y1. Similarly, OV, the distance from O to V is x2, distance from O to U is x, and distance from O to T is x1. Now let us consider the triangle APD and triangle PBE. In these two triangles, we see that angle ADP is equal to angle PEB equal to 90 degrees. They are right angles as we have dropped the perpendiculars AD and PE on PU and PV. Similarly, angle PAD will be equal to angle BPE. And why are these angles equal? Because they are corresponding angles. When the lines are parallel, the corresponding angles are equal. So this angle here is equal to this angle here. Angle APD. So triangle APD is similar to triangle PBE. And if the triangles are similar, then the corresponding sides are in equal proportion. So the corresponding sides are AP and PB. The ratio of AP and PB is same as the ratio of AD and PE is same as the ratio of PD and BE. I hope this much is clear to everyone. Now our aim is to find the value of AD, PE, PD and BE. Okay, AD is equal to, I can write AD as x minus x1. Similarly, DE can be written as x2 minus x. PD can be written as y minus y1, and similarly BE can be written as y2 minus y. The ratio which we have got is AP over PB is equal to PD over BE is equal to AD over BE. Let us substitute the value. AP is M and PB is N. So M over N is equal to y minus y1 over y2 minus y is equal to x minus x1 over x2 minus x. So we will be taking this equality first. Now M over N is equal to y minus y1 over y2 minus y. Our aim is to find the value of y. So let us cross multiply. So we get m times y2 minus y is equal to n times y minus y1. My2 minus my is equal to ny minus ny1. My2 plus ny1 is equal to y plus my. So my2 plus ny1 is equal to, take out y common and we are left with an m plus n. So from here we get y is equal to my2 plus ny1 over m plus n. And similarly we can take m over n is equal to x minus x1 over x2 minus x. And when we simplify it, we will get x is equal to mx2 plus nx1 over m plus n. We will be simplifying it the same way as we have simplified for y, and this is our section formula.
That let's consider two towns, say town A and town B, and let's say we know the locations for these two towns. Locations, that is coordinates. So let's say coordinate for A as 2, 3 and coordinates for B as 5, 6. And the postal department wants to place a post box P anywhere in between A and B, such that it divides the line joining A and B into two sections, and those sections are such a way that distance between A and P is twice the distance between P and B, and therefore it can be represented as AP upon PB equals to 2 upon 1, and therefore we can say that ratio of their distances, that is AP is to PB, is 2 is to 1, which indicates that if the distance between A and B is divided into 3 equal parts, then 2 parts will be on the left side of P, that is towards A, whereas 1 part is on the right side of P, that is towards point B. And main aim of this session is to find the coordinates of P, that is x and y. So let's start with x. X coordinate of A is 2 and x coordinate of B is 5. Looking at the ratio 2 is to 1, we realize that we need to find the value of x in such a way that if the distance between 2 and 5 is divided into 3 equal parts, then 2 of the parts will be towards point 2, that is x coordinate of A, and 1 part will be towards 5, that is x coordinate of B. And this can only be done by the point 4 on x-axis. So therefore, value of x coordinate of P is 4. Now you can see that distance between 2 and 5 is divided in the ratio 2 is to 1. Now let's repeat the same process for y-axis as well. So y coordinate of A is 3 and y coordinate of B is 6. And we can see that 0.5 follows the ratio 2 is to 1. So therefore, value of y coordinate of P is 5. We got the coordinates for point P very easily because the ratio was very small, that is 2 is to 1. So we have divided the total distance into 2 plus 1, that is 3 equal parts, to locate the coordinates for point P. But it becomes very difficult in case of big ratios. Like for example, say the ratio is 10 is to 15, then I have to divide the small distance into 10 plus 15, that is 25 equal parts, to locate the coordinates of the point. So this was just an example, but from this example we understood that locating the coordinates of point in this way for big ratios is very difficult. So we require some mathematical trick which will help us to find the coordinates of P in case of big ratios as well. So let's start with the x-axis and let's try to find the trick for getting the value of x as 4 using the given values. And the given values are, now observe this carefully, multiply first part of the ratio, that is 2, with x coordinate of the second point, that is 5, and multiply second part of the ratio, that is 1, with x coordinate of the first point, that is 2. Add them and divide with the addition of the components of the ratio, that is 2 and 1. On calculating, we get 12 upon 3, which is nothing but 4, which is the exact value of x for P. So similarly, let's repeat the same process for y-axis. We have to get the value of y as 5 by using the given values. So multiply the first part of the ratio, that is 2, with the y coordinate of the second point, that is 6. And second part of the ratio, that is 1, multiply this with the y coordinate of the first point, that is 3. Add them and divide by sum of the two components of the ratio. We get 15 by 3, that is 5. The exact value of y for the point P. And interestingly, this trick works for any ratio, whether it is small or big. So let's try to generate a general formula which will help us to find the coordinates of the point using any ratio. So for that, let's consider any coordinates for point A and B. Let's take A as x1, y1, and let's take B as x2, y2. And let's take the ratio as m is to n and follow the same trick. We will get value of x for P as first part of the ratio multiplied with the x coordinate of the second point added to multiplication of second part of the ratio and x coordinate of the first point and divided by sum of the components of the ratio. Similarly, we'll get the value for y. So y equals to first part of the ratio is multiplied with the y coordinate of the second point, that is added to multiplication of second part of the ratio and y coordinate of the first point divided by sum of the components of the ratio. So therefore, we can say that x comma y, the unknown coordinates, can be found out using this formula. This is called a section formula.
Children, let's recap the today's class.
Section formula. The point P, which divides the line segment joining the 2 points A of x1, y1 and B of x2, y2 internally in the ratio m is to n is P of x, y is equal to P of mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. The section formula can be used only when the given 3 points are collinear. Learning outcomes. At the end of the class, children are learnt about the section formula and how to find the coordinates of P, which divides the line segment, using the section formula. Let's finish this class with eye exercise and Shanti mantra. Thank you. Hari Om.
And become aware you want to be grateful to your eyes and you want to do something good for your eyes. Open your eyes, look towards the right and towards the left, towards the right, left, right, left, right, left, right, left. Close your eyes. Open your eyes again. Look up, down, up, down, up, down, up, down, up, down. Close your eyes. Feel your eyes. And with each exhalation, send relaxing energy from your abdomen to your eyes and through your eyes. Open your eyes again. Now look to the upper right, lower left, 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 upper right, lower left. Close your eyes. Open your eyes again. Look towards the upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right, upper left, lower right. Close your eyes and send relaxing energy from your abdomen towards your eyes. Open your eyes again and make no circular movement clockwise. Look up and then slowly to the right and to the bottom and to the left and up to the right, down, and continue a few times. Try to make it complete circles and not just squares. This practice also helps of the brain. No, other direction, counterclockwise. Do slow conscious movement. And slowly close your eyes and feel. Now open up your eyes again and stretch out your right arm, thumb, the level of your eyes. Look towards your thumb. Look far away. Back to your thumb. Now look towards the tip of your nose. To your thumb, far away, your thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, far away, thumb, tip of your nose, thumb, and far away. Close your eyes. Now, lift up your hands a little bit and rub your palms, warming up your palms and increasing the life force, the prana in your hand and your hand chakras. Put your palms over your eyes and feel the energy of your palms radiate into your eyes. Feel that calming, soothing, relaxing energy. Slowly relax your hands, lower your hands. And you can do this wonderful breathing exercise every day. Your eyesight will improve. You don't need to get headache. And you come to clearer and clearer insights. Lisa and Sukadev wish you a day full of insights, full of calmness, peace and compassion.
Purnamata Purnamidam Purnat Purnamudachyate Purnasya Purnamataya Purnameva Vasishyate. Om Shanti Shanti Shanti.